Hello students and friends, most welcome to Dr. Acharya Academy. Today I am going to discuss the Dalton's law of partial pressure. This topic has been taken from the unit 5 of the CBSE chemistry class 11 syllabus. Today's class number is 103. Dalton's law of partial pressure, this is formulated by scientist Dalton in the year 1801. So what Dalton's law of partial pressure that we'll see now? The total pressure exerted by the mixture of non-reactive gases. Gases should not be reactive to each other, that you have to remember. And this total pressure is equal to the sum of partial pressures of individual gas. So now what is the partial pressure? The partial pressures of individual gas are the pressure which these gases would exert if they were enclosed separately in the same volume and under the same condition of temperature. It means that if individual gas, suppose we are considering oxygen gas, nitrogen gas, this oxygen gas at the same volume, that means in same enclosure having fixed volume and at constant temperature, which pressure it will exert, it's called its partial pressure. And similarly for the nitrogen gas also, in the same enclosure having same volume, if we keep at the same temperature, then the pressure it exerted to the wall of the container, that it is called the partial pressure of nitrogen. So in this way, we will calculate the partial pressure, and which is the part of this Dalton's law of partial pressures. So this is very important law, we have to remember. And in addition, what is the partial pressure? You have to incorporate in writing also. Now, in a mixture of gas, the pressure exerted by the individual gas is called the partial pressure. I already discussed now. And then mathematically, you can write this Dalton's law of partial pressures. Equation is P total. P means pressure, total means total of the partial pressures of gas. It is equal to P1 plus P2 plus P3 plus dot dot, and at constant temperature and volume. This we have to mention always. When you will write some pressure calculation, then we have to write that temperature and volume to be constant in this case. Then this P total is the total pressure exerted by the mixture of gas, and P1, P2, P3, etc. are the partial pressures of gas. So this equation is the mathematical form of the Dalton's law of partial pressures. Now we'll see that how to calculate the pressure of dry gas. Gases are generally we collect over water, and so it is moist. Now the pressure of dry gas, how to calculate? By subtracting vapor pressure of water from the total pressure of the moist gas, which contains water vapors also. So pressure exerted by the saturated water vapor is called the aqueous tension. So for the calculation of the pressure of the dry gas, we have to consider this aqueous tension. That means pressure of dry gas is equal to total pressure minus aqueous tension. Here is a list of some relating parameters, temperature, pressure, and temperature pressure. When the temperature is in left side column and right side the pressure columns is there, and similarly last two columns also like that. So now we have to consider at temperature T three gases which are enclosed in the volume V. Then these three gas exert the partial pressure P1, P2 and P3 respectively. Then the equation as per the ideal gas law, what I already discussed in the previous class, then P1 is equal to N1RT by B, and similarly P2 is equal to N2RT by B. And this N1, N2, and in the next N3 also will come, all are the number of moles of this gas. This is the N3. So now, as per the Dalton's law of partial pressure, we consider the total pressure, then it is equal to the partial pressures of the individual three gas, that is P1 plus P2 plus P3. And now we have to put this value for P1 N1RT by B plus for P2 N2RT by B plus for P3 N3RT by B. So if we simplify, then N1 plus N2 plus N3 within bracket multiplied by the RT by B. Similarly, for other two gas, we can write also P2 is equal to X2 P total, and for P3 X3 P total. So we can consider as a general equation Pi is equal to Xi P total, or this Pi and Xi are the partial pressure and mole fractions of ith gas respectively. So if the total pressure of a mixture of gas is known, then this equation we can apply to find out the pressure exerted by individual gas, that partial pressure. With this equation, if we know this P total and Xi, that mole fraction already will know, and then this partial pressure we can calculate very easily. Now we'll check one problem, mathematical problem, using this equation of the Dalton's law of partial pressure. A neon dioxygen mixture contains 70.6 gram dioxygen. Dioxygen means it is the oxygen molecule. We should write as the dioxygen. And 167.5 gram of neon. If pressure of a mixture of gas in the cylinder is 25 bar, then what is the partial pressures of dioxygen neon in the mixture? First, we have to convert this gram of this individual gas, dioxygen neon, in the number of moles. So dioxygen is 70.6 gram. So 70.6 gram is divided by the molecular weight of dioxygen, which is 32 gram per mole. Then number of moles of dioxygen in this case is the 2.21 mole. And similarly for the neon, the number of moles we have to divide by the weight of the neon, which is 167.6 gram, divided by neon's molecular weight 20 gram per mole, and ultimately the number of moles of neon is the, after calculation, 8.375 mole. So now mole fraction of the dioxygen in respect of this mixture, neon dioxygen mixture, what it will be? We know the number of moles fraction of dioxygen will be the number of moles divided by the total number of moles involved in the mixture. So mole fraction of dioxygen is 2.21 divided by these two, we have to add, that is 2.21 plus 8.375. After calculation, the mole fraction of dioxygen is the 0.21. So here you can see that in this problem, we have to convert the individual gas, this dioxygen and neons, in respect of the mole fraction from the amount. And similarly, for the mole fraction of neon, after this calculation, here this 8.375 mole divided by the all moles you have to add, it will be divided by, same way when you calculate the mole fraction of dioxygen, that means 8.375 divided by 2.21 plus 8.375, and ultimately the value of the mole fraction of neon is the 0.79. So alternatively, we can write also, because it is two gas is involved, so one gas mole fraction you know, so from 1 minus 2.1, then whatever the mole fraction is there, that is for the second gas, that is the mole fraction of neon. In this way also we can calculate. So now partial pressure of the gas, this previous equation I discussed, that Pi is equal to Xi multiplied by the P total. So P total we know, this is the 25 bar. So now the partial pressure is equal to, for oxygen, dioxygen, this is the 2.21 mole. That means fraction is the 0.21 for the dioxygen, and multiplied by the total pressure 25 bar. So after calculation, it will be 5.25 bar. And similarly for the partial pressure of the neon, mole fraction of the neon is 0.79 multiplied by the total pressure 25 bar. And again the partial pressure of neon, after calculation, it will be 19.75 bar. I hope that you understand very clearly Dalton's law of partial pressure and how to calculate the partial pressure, and it will be very helpful for your exam. Thank you so much for watching this class.